And now we can see that each object, each box has a number associated, and the same motorbike or the same vehicle has the same number while moving. Hi there, my name is Sergio and I help students, companies, freelancers how to easily and efficiently apply video recognition to their projects. In this specific video today we're talking about object tracking. You should know that there is a crucial difference between object detection and object tracking. The object detection is the detection of the objects done on each single frame. Even if we have a video, it will be detecting the object frame after frame. While object tracking will be keeping track of the object of the objects detected during all the frames to have an history of where that object was over time. And if you want to make applications like counting people entering on a certain area, counting objects passing on a conveyor belt, or counting the cars that are passing on the highway, or tracking and drawing the trajectory of an object, then object tracking is something that you absolutely need. And in this specific video, we're going to focus at the beginning on object detection. So the first part will be on object detection, and you will be learning how to detect objects. And then in the second part of this video, you will be learning how to apply object tracking to the detection. So let's start. To work with this project, we need three files. First, of course, we need a video where we want to track the objects. In this case, I have a video which is highway.mp4, where there is a camera from the top of the highway where we can see motorbikes and cars passing by. And with this video, our goal will be tracking cars and motorbikes that are moving, and so see the counting of them. And this is the first file. The second file is an object tracker. This is a file that I've written which will do the tracking, and so you need to download this one from the link below because we will be using this one. Video plus tracker, and then an empty file which we will be coding right now live, which I call main.py. You can call that as you wish, and this is the file that we will run and will import the tracker. And so without adding anything else, let's start with coding the main.py file. First of all, I'm going to import the CV2 library, which is Opencv, which we will be using for the detection of the objects, in this case, the motorbikes and cars. Then, once we have CV2, we also want to create a capture object to read the frames from the video. So cv2.video capture, and here we need to put the path of the video file. In this case, it's the highway.mp4 that I have on the same folder. So just to try with me, I suggest that you download the file so that you can have the same video to try this out. Then, once we have the capture object, we need to start a loop while true, because considering it's a video, we need to extract the frames one after another. So on each loop, we take one frame. So it will be ret frame equals cap.read. Now we're going to show the frame in real time. cv2.imShow frame, then frame. Now await key event key equals cv2.wait key 30. If the key is 27, I know now it's a lot of things. So once we show the frame in real time, we need also a key event so that if we want to close the video, we can just press a key. In this case, we say if the key is 27, 27 is the ESC on the keyboard, we break the loop. And then cap.release, and then cv2.destroy all windows. And now, to make sure that everything is correct, I'm going to run this code. So this is exactly the same video that we were seeing before, but I am using this from Python and Opencv. Now, our goal is to detect the motorbikes. And how do we detect the motorbikes on this specific video? Well, there are many different object detection methods. If you want to learn more about object detection, I have a full video course called Object Detection with Opencv and Deep Learning, where you can learn how to efficiently detect anything on any kind of environment. In this case, we will be using an object detection method for a stable camera. What does it mean? We have a stable camera, which means that the background is always the same. The background is the highway, the road doesn't change over time, while there is only the objects that are changing over time. So using the object detection method with a stable camera, we are able to extract only the moving objects. And so let me use here the object detection from stable camera. We need to create the object detector, so will be object detector equals cv2.create background subtractor mog2, and we will get we'll see some more information about this later. For the moment, you need to know that this object detector is going to extract the moving objects from a stable camera. How do we know and how do we extract them? Well, we need to do this in real time here by creating a mask equals object detector dot apply, and then here we want to apply the detection on the frame right here. And now let's show the mask so that we have a clue of what we are doing in real time. cv2.im show mask and then mask, and now we get a mask. The goal of a mask is that makes everything that we don't need black, while the objects that we want to detect white. So in this case, that we have a highway and then we want to detect vehicles like motorbikes, cars and trucks. All the vehicles must be white, while all the rest needs to be black. In this case, the detection of this method is probably not one of the best because we have so many white elements, but still, considering that, as you can see, the motorbikes and the cars are more white, so they are bigger than all the other elements, we can discard everything that we don't need. So we can see this step by step. To do this, the best way now is to get the coordinates of all the white elements and then remove all the really small elements that we don't need. So for example, here we have the trees, we have a lot of small dots, while for the cars we have like big white objects moving down. So this can be one way to solve this problem. If that's not enough, if it won't be enough, we will find for sure another solution. So from the mask here, we will start with object detection. Object detection. From the mask, we need to extract the coordinates. So for this, we use an Opencv function, which is cv2.find contours. We want to find the contours of the boundaries of these white objects on the mask. Then the mode cv2.ret3 and the method cv2.chainApprox simple. These are some technical stuff, ret3 and chainApprox simple, that we don't really need to get into. Pretty much is how we extract the information, but nothing more. As long as we get the contours, that's fine. So we need to get contours and hierarchy, which we don't need, so we only need this one. Then we can say for CNT in contours, and we can now see what are these contours. cv2.draw contour, we want to draw them now on the frame. Then CNT, we want to draw one by one, -1 to say that we want to draw all of them. Then let's make it green, 0, 2, 55, 0, and thickness, let's make this 2. Now, as you see, everything that is white on the mask, we are surrounding here with green contours. But here we have a lot of things that we don't need. So as I said before, let's remove all the small elements. To remove the small elements, we can first calculate the area. Calculate area and remove small elements, and then area equals cv2 dot contour area of CNT. Then we can put an if condition. So we can say if the area is less than, for the moment, let's try less than 100 pixels. Then in this case, we don't want to do anything. So let's say if it's greater than 100 pixels, we draw the contour, otherwise we don't draw them. And have a look how nice we got this result in this moment. So already putting contour greater than 100 pixels, of course we have a lot of things that we don't need, but we achieved some interesting result. I don't want to make this tutorial quite complicated, so if you want more advanced stuff, I will suggest you to go on the link below and see the object detection course, while in this case we are going to select a region of interest ROI, and we will focus only on this specific part of the road, and we will focus only on the vehicles on this road so that we can track them correctly. So let's now define an ROI, which will be region of interest. So we need to extract some portion of the image. So extract region of interest. This will be ROI. To extract an ROI, we need to define from which position from the image we want to extract that. Well, one way first to know from which position will be to show how big is the entire frame. We have height, width, and the channels, which we don't need, so only height, and we will be frame.shape. So if I print height and width, we have 780 of height and 120 of width. This means that if we want this region, which is more or less in the middle of the screen, will be the X position around 500, I can guess, from 500 to 500 to, let's say, 700. I'm just guessing now, not to take time just to find the best coordinates, otherwise I will make the lesson really long. So frame from 500 to, I will say, 700. And now we also need to put the height, not only the width. So the height, it was also from the height on more or less on the middle, let's say from 340 to 600. Let's see what we get. I'm going to show now the ROI. cv2.imShow ROI, and then ROI, and let's see what we get. It's more or less it's what I wanted to get, but it's really small. So let's increase this. Let's make this ROI from this side to this side and to exactly the bottom of the window. So I'm going to increase still around 100 pixels to the right side. And I can do that right here. So from 500 to 800, and then from 340 to the maximum of the height. So here we're defining where it starts the height that we want to cut to the end. Then the width starts from 500 to 800. And this is already an interesting section that we can work with. So we'll be tracking the vehicles that are only coming inside this area. And this will make our detection much easier. So what do we do now? we want to make the detection only on this area, so the mask that we were applying on the entire frame before, we are going to apply it right now only to ROI. And so also the contour, we're going to show them only on ROI. And let's see what we get. Now something more interesting is now it's working better than before, still not exactly as it should, but it's better than before. I want to quickly improve the detection of this one, and then we can move on the tracking. So as the detection is not working fine, we need to make some change on the object detection algorithm, which is this one, by applying first the history. So we're going to change the size of the history that the algorithm processes the images. The longer the history, the more precise will be, but of course it will hardly adapt to the changes if the camera moves. In this case, the camera is quite stable, so we can try with history of 100 and then var threshold. Here the lower the value, the more results we get, but also there's the chance that we get many false positive. So for example, if I give 5, you see we have more white, more detection, but more false positive. And here we see a lot of wrong greens. While if I put a higher value, we can try around 40 or higher, there will be less detection, but less false positive. So we need to find the best range that fits for our project. And this one is quite fine. From this, we can now extract the rectangle from this surrounding, and we can see how the detection of the cars and vehicles is working. So let's do that right here. I can go on the contour. Instead of drawing all the contours, we're going to extract the rectangle, so the box that surrounds each object detected. And we have x, y, width and height, which is CV2 dot bounding rect of C and T. And from this we can draw the rectangle. CV2 dot rectangle. We want to draw the rectangle on ROI. Then we have point 1 x and y and point. So we need the top left point and the right bottom point. Right bottom will be x plus width, and then y plus height. Color, let's make this green 0, blue 2055 of green 0, of red, and thickness, let's make this 3. And let's see what we get. It's not the best detection, but it works. One last thing that I will add, and then we will move right away on object tracking, is this algorithm is giving us not only the object, but also is detecting the shadow. So we see white objects and gray shadow. So if you have a quick look at this, we have the motorbike white and the shadow gray. We don't want to detect the shadow, so let's only keep all the elements that are completely white. For this case, we're going to clean the mask. Mask will be equal to CV2.threshold. With this threshold operator, we're going to remove all the pixels that are gray and keeping only the white pixels. A threshold of the mask, all the value that are above 254. So keep in mind, the pixels have value from 0 to 255. 0 is completely black, 255 is completely white, and on the middle we have different gradients of gray. The closer to 0, the more it's dark, the closer to 255, the more it's white. So as we want only the white, we want to remove everything that is 254 and below, and all the rest will make white. So from 254 below, we remove it, all the rest will keep it white. And this is operation CV2.thresh binary. So if I run the mask now, you can see how well now the motorbikes are detected, because all the white from the shadow was removed. I'm quite happy with this result that we got quite already live. Now, this is object detection. So we know, we see now this motorbike here is surrounded by a green box, but we have no clue, at least on the code, of where this motorbike was before on the screen. So we're now going to apply object tracking, and let's do that. For object tracking, we need to import the file that I've created. So if you don't have that, download this file and put it on the same folder and then import it from tracker. So you need to put the file tracker.py on the same folder. We're going to import everything. And just at the beginning, we're going to create tracker object. Tracker will be equal to Euclidean dist tracker. How does this work? This tracker takes all the bounding boxes of the objects. So we need to save all the bounding boxes of the object into one array. So it will be object detection. Here we discard all the elements that we don't need, and we find only here, if the area is greater than 100, we find the bounding boxes of the object. So all these x and y, width and height, we need to put them into one array. So here we print x, y, width and height. I will quickly show this one. Let's now get one object. We see 141, 222, 1369 is this bounding box. Let's see, now we have two, and here we have two of them. We want all these numbers together inside one array. And we can easily do that by saying detections. It's an empty array. Each time we find the boxes, we're going to put them inside detections. Detections dot append, and we want to append x, y, width and height. So if we print detections, now of course it's empty. Now I'm looping frame after frame on the video. Now it's empty because we don't have anything detecting. Now second frame empty, third frame there is nothing. Let's go. Now we have one object detected, one motorbike. Here we have x, y position of this motorbike, the width and the height of this rectangle containing the motorbike. When we have more motorbikes, now we have two of them detected, so the array will be containing two bounding boxes. The first one, first motorbike, second one, second motorbikes. And this works, of course, the more motorbikes we have, the bigger the array. So now we have three motorbikes. Let's see, and now we have three boxes, 1, 2, 3. What do? We give this detections array to the tracker, and the tracker in return is going to give us also the history, so an univocal ID that is associated to each motorbike, and we will see how to work with that. Tracker, so here we have object tracking. So remember, first step is object detection, is step 1. Only if we have object detection, of course, we can make object tracking. So the second step will be object tracking. And now we need to have detections, let's say boxes IDs equals to the tracker.update, and we want to give the detections. So let's now see what's happening with the tracker. I'm going to print boxes IDs. And I'm going to wait until we get some object. Let's wait till we have two objects detected together. Okay. Now we have object 1 and object 2. And here we see we have the array, so we have two objects, so we have two arrays, and that's exactly as we had before. But there is something more. We have x position, y position, with height plus ID. So here we have 3. Then we have x, y, width, and height plus ID 4. So what does now happen? That on each frame we do not only have the bounding boxes, but also we have a unique ID. And we know that one of these objects is ID 3 while the other is ID 4. So if we go on the next frame, so we move a bit, still there will be different position, but still ID 4 and ID 3. So this means that we know that this object has its ID, and we don't exchange that by mistake with other objects. And this is important if we want to count the objects passing by. This is essential for that operation. So let's draw everything that we have right here. We have CV2 rectangle. Now for box ID, in boxes IDs, here we show, we extract x, y, width, height, ID is from box ID, and the rectangle, we're going to show the rectangle now from the tracker, not anymore from the detection, because now we also display the ID. So we do cv2.put text. We want to put the text where? On the ROI. Now the text we want to show just the ID, it's the string of ID. Now the position, let's put this on x and y position -15. So I'm going to put the ID just following the object. So x is the position of the object, y -15, so it's not exactly over the object. So we have the number a bit higher than the object. So that's, I'm using -15 just to give a small distance from the object. Then the font, we can use cv2.font hair shape plain. It doesn't really matter the style of the font, we don't care about that right now. Color, let's make this blue, 255 blue, 0 of green, 0 of red, and 2 of thickness. And let's see what we get. So you see we have ID 3, ID 4. Let's make this in real time. So, by the way, keep in mind, if you put wait key 0, it keeps the image on hold until you press some key. If you put a number higher than 0, it will wait dot milliseconds. So this will wait 30 milliseconds between each frame. Let me increase a bit the size of the ID, let's say 2, and let's see what we get. And now we can see that each object, each box has a number associated, and the same motorbike or the same vehicle has the same number while moving. And thanks to the IDs, we are able to detect, to count correctly the objects that are passing by if we want to. For example, we could draw right here a line, and we can check, has some ID crossed that specific line? If so, then we can increase the count. Of course, this was just a really simple explanation of object tracking with a simple method, and it's not perfect. As you see, the camera now is moving a bit and there is some error on the detection. I hope this was useful for you. I put a lot of things. I know that it can be overwhelming if you are a beginner, so I suggest you play around with this. But if you want to understand all the secrets of object detection and object tracking from the basic to understand first how to detect objects in a certain space, and also which method to choose to detect the objects, and then a best, more sophisticated and reliable object tracking method, I will highly suggest you to have a look on my video course, Object Detection, Opencv and Deep Learning. I hope you enjoyed this lesson, and I'm going to release soon new videos and see you on the next lesson. Bye.